the warm-up are up there. I was going to go ahead and take some time to go over those as Ms. Goldstein and I are walking around. Number 1 looks awesome. Remember, it did say leave your answer as a simplified radical. You know, if it doesn't have those directions, you get to pick. If you have a rational exponent, if you have 12x to the 13/12ths, that is a correct answer, but because the directions here said leave your answer as a simplified radical, you did have to go a little bit further. 12 is raised to the first power, and then x is raised to the 13/12. So the only thing that has a radical around it is the x. So I did the 12th root of x to the 13th, and then asked myself, how many times does 12 go into 13? The answer to that's 1. And then, so I get 12x times the 12th root of x. So you had to add the exponents together, Kristen. So 1/3 plus 3/4. The common denominator is 12. If you need to do a middle step for this problem, I understand. Like if you need to rearrange this. You know, that's not a bad thing. And then these are like bases multiplied together, so these exponents are what we add. And then some of you do have to show a little bit of scratch work. I understand. It's been a while since you've done fractions in this way. Common denominator is 12. So this, you know, top and bottom got multiplied by 4. 1/3 is the same as 4/12, and then top and bottom by 3 here. If you're adding 4/12 and 9/12, that's where the 13/12 comes from. Does that help you out, Kristen? Number 2, I'll go ahead and talk about that a little bit if there's no questions on number 1. Okay, so let me talk to you a little bit about number 2. There's definitely more than one way to look at it, which always makes things a little bit tricky, but here's how I saw the problem. First thing I was like, oh, you know, I have to distribute those exponents into the parentheses. That is something you're allowed to do as long as there's no plus or minus in the parentheses. So do you see what I did there? I took my 1/2 and I distributed it in. And then I took my 1/4 and I distributed it in there. So that's that first step. Everybody okay so far? Next step. I did my associative property of multiplication to rearrange the multiplication and make the problem just a little bit easier. So I grouped my x's together, and then I grouped together 2 to the 1/2 power times 3 to the 1/4 power. The x's are pretty easy to deal with. You just had to add a 1/2 and a 1/4, and that's 3/4. 50 cents and 25 cents is 75 cents, or 3/4. So that part is usually okay. Now here's where the rubber hits the road, so to speak, on this particular problem. We had to find a way to simplify 2 to the 1/2 times 3 to the 1/4. Now, Ms. Goldstein and I saw it 2 different ways. I'm going to talk about mine if it's okay, and then she's going to talk about hers. So when I saw it my way, I was like, oh, you know, if they were like bases, I would try to add the exponents, and that's what made me think like, oh, well, they could have the same denominator. You know, if you were adding a 1/2 and a 1/4, the LCD would be 4. So when I did that, I was like, oh, a 1/2 is just 2/4. So that's where the 2/4 came from, right there. Then what I did was like, oh, they both have a denominator of 4. So I'm going to use the power property in reverse, and I factored out 1/4. And what was nice about that, after you pull out that factor of 1/4, the numerators just come down. So I had 2 squared and then 3 to the first. And then that's just 12. So I had 12 to the 1/4. So that's how I saw it. But then Ms. Goldstein saw it another way.
I immediately saw during this step that if I changed it to radical form right there, that I could have 2 squared, the 4th root of 2 squared, times the 4th root of 3. Now, if you have the same indices, you can multiply with them and not in the radicand. So that's where it kind of matches up right here, but in different form. So I also had 2 squared times 3 to the 4th root. So it matches up. It just, we both wrote it.
So hopefully that addresses your issue with the 12 to the 1/4. That could also be right there, the 4th root of 12. So I'm going to scroll back up just a smidge so that you could kind of see our solution up there, and then how we arrived at the simplified radical version. Now, I'm so sorry, Megan. I totally see you. Give me 1 second. I gave a study skill at the beginning of the chapter. When you run into a problem, because I know some of you are sitting there and like, okay, I see that, Mrs. Lucas. Miss Goldstein's way makes sense. Your way kind of makes sense. You know, maybe you're saying something like that. But then you're also saying to yourself, I never would have thought to factor that out on a test. When you run into that type of problem, because there's not going to be very many of them, those are problems that give you that flexibility of thinking that I need you to get in this class. They're going to be on your test. What I need you to do, when you see a problem and you're like, oh, I wouldn't have thought to do that, on the inside cover of your note packet, that's always blank. It's a bright yellow page. Put the weird stuff on there, and then you all know it's in one spot. So the weird stuff, the stuff that you think you never would have thought to do on a test, just copy that problem real quick on that yellow paper, and then you have a one-stop shop of problems to study for when you come in to take your test. And that's a technique that several of my other classes are utilizing this at this point. I don't know that a ton of you are necessarily doing that, but it is a nice option. That colored piece of paper is always blank on the inside cover of your note packet, so write your weird stuff there. That strategy is super helpful in this chapter and super helpful in chapter 12 when we study sequence and series. Sometimes you're going to see a sequence and be like, I don't know what that pattern is. I wouldn't have thought that pattern were that way on my own. Write it down, and then if it's on the test, you get it, because those are the problems you study. Does that tip make sense? Yeah. Okay, Megan, you had a question. Go ahead. Oh. Square root of 2, 4th root of 3. We don't have a product property for when the indices are different. So that's why rational exponents are actually necessary. That's the purpose behind them, is that because we don't have a product property for radicals, we can turn them into rational exponents and use our properties of exponents to help us. So that's why we have these, So yeah, there's no cute little trick around that. I wish I had a better answer, but I don't. That's what I got. That's what math has for us, Okay. All right. And then you had one more. You had number 4. And then today's lesson's pretty short because I'm spending a nice long chunk of time on your warm-up today. We're going to do one more skill, and then I'm going to trim down your book assignment a little bit. I did this for my other classes too. Trim down your book assignment a little bit, and then we'll finish the lesson tomorrow. So number 4, you're just checking that. If you're like, wait a second, I got plus or minus the square root of 1 over 5, but why all of a sudden is it plus or minus the square root of 5 over 5? You could look on the sideboard over here. You had to rationalize the denominator. You know that you can't leave a fraction in the bottom, a radical in the bottom of your fraction. So you did have to rationalize there. In addition, I see some of you jotting some things down on the inside front cover of your notes. It might be good to write the section it came from. This is 6-6. And then if you are really struggling with how did she get that, you can go back and watch the video again, because, well, we are recording for you. So it's nice. If you're like, oh, I just need to see that one more time before I take my test, you know where it is. I'm going to pause for a second so this video isn't too long. So you can go ahead and turn the page right now to our next example. Little word problem, word up. This problem has gone really, really well today. I'll go ahead and say that. Step 1 is you read the problem. So you're going to take a quiet moment to read the problem, and you're going to make a list. You need to identify what you know and identify what you don't. And then if you can go further, do it. students that have this one set up correctly, that's what it's looking like, I think. So for those of you that are meeting with some success, that's the answer I'm seeing up there. About 938.16 millibars is what you're looking at for your pressure there. Pretty interesting little problem about hurricanes. I liked it. So I used it. Does anybody have any questions about that one? I see some questions. Maybe. Riley, you all right? Caitlin, are you good? I did. Remember, we isolate the radical first. Now, Caitlin, in all honesty and being very candid, you could have jumped right there into squaring both sides. So you would have done 6.3 squared, that number there, times the quantity of 1,013 minus P. And then you would have squared the other side as well. You would get the same answer, regardless. Oh, okay, okay. Yes. It's fine. It's fine. You're going to be off? Yes. You'll be, to be honest with you, I got that answer by not rounding at all. And I was just kind of roughly jotting down rounded answers, but I was carrying it through the entire time on my calculator. So I didn't actually round to produce that answer at all. I let my calculator do all the walking and rounded my final answer. But for the sake of taking notes, like, you have to put something down. So I rounded to show what could work for you. Questions about that? Yeah, I usually try to avoid, and that's good practice, to avoid rounding until the very, very end. All right, so now our big skill for today, remember that in this problem, we did try to isolate the radical first. That is usually step one. But as you even saw on last night's assignment, it's not always possible. Do you remember? Can anybody remember a case from their homework last night where that wasn't possible? You couldn't isolate the radical first? Kristen. Number two, super irritating, right? You had to square the whole left side and then square the whole right side first. Did everybody see that? Because it's kind of critical. Yeah, all right, perfect. So now, today's situation is our big idea for today is just that. Like, what do you do if you can't isolate the radical first? So let's talk about that. In our next example, and I have to tell you, if you're a person that writes very large, you need to write smaller because there's kind of a bit of work to show for this problem. So write small if you're a person that writes large. If in example 3, I'm going to do part A and you're going to finish up today doing part B. If you take a look at the first step there, we have the square root of x plus 6 plus 2 equals the square root of 10 minus 3x. Try step 1. Look at it for a second. Try step 1. Isolate that radical. Can you? No. So because you can't do step 1, it doesn't mean you like stop and go get yourself a sandwich, as I sometimes say. It would be nice. Go get a snack. No. You have to go into step 2, which means you're going to eliminate at least one of the radicals by squaring both sides. So if I square the right side, right now I'm like, oh, sweet, the radical went away. If I square the square root of 10 minus 3x, I just get 10 minus 3x. So pretty happy about the way the right side of that equation turned out. Presently, I need to take my own advice and write small. Next, I got to square the left side. Am I allowed to just distribute that exponent into that set of parentheses? Take a vote, because I'm seeing mixed results. Who says yes? Let's just distribute that squared in there. Ooh, who says no? That's like the rest of you, right? Yeah, very good. All of you. So, yeah, you can't. Some of you maybe were unsure. We can't distribute that squared in because of this guy right there. Oh, that plus sign, it messes up your day. This is going to be a FOIL problem. So we have to, yes, you can groan. Groaning completely allowed at this point in time. Oh, because it is long. Okay, so we would FOIL that. Now, real quick, there's a shortcut for doing the firsts, and I'm going to ask you a series of simple questions. Shout out the answer if you know it. You ready? Square root of 3 times the square root of 3. which is 3, okay? You're right. Square root of 3 times the square root of 3, that's 3. Okay, let's do it again. Square root of 7 times the square root of 7. Square root of 5 times the square root of 5. Square root of 13 times the square root of 13. Square root of 9 times the square root of 9. Okay, I think you get the idea. Good. So if I take the square root of x plus 6 times the square root of x plus 6, you get, very good, your outers. We're taking 2 times the square root of x plus 6. That's just 2 root x plus 6. Your inners, 2 root x plus 6. And your last is 4. Now, when I FOIL, you folks know that we can normally combine our O and our I, combine our OI. So I'm going to go ahead and simplify the left side by combining like terms. I do have like radical parts there, so I can put those together. And then I have some constants. 6 and 4 I can also put together. So to simplify that left side a little bit, we have x plus 6 and 4 is 10. And then 2 times the square root of x plus 6 plus 2 times the square root of x plus 6 is 4 times the square root of x plus 6. And then that's equal to 10 minus 3x on the right side. Just to be very clear, you'll see that when I put together 2 square roots of x plus 6 plus 2 square roots of x plus 6, I did get 4 square roots of x plus 6. And then the 6 and the 4 is where I got the 10. So I FOILed the left side. So now I start over. This is a radical equation again. I have to isolate and then eliminate, factor, and solve. So I'm basically starting over in the process. And you can groan. It's totally okay. Oh, okay. So see how I have 10s on both sides of the equal sign? Addition property of equality says, hey, it's like that addition never happened. So I can go ahead and cross off those 10s. And then I'm going to subtract x from both sides. So if I subtract x from both sides, I have negative 4x on the right. Negative 3x, take away an x, is negative 4x. Questions so far? Okie dokie. Do you see how there's a 4 and a negative 4? I could divide both sides by 4. Again, I'm trying to isolate the radical. So what I get there is the square root of x plus 6 equals negative x. I'll square both sides. Remember, when you square a negative, you get a positive. So I get a positive x squared on the right side there. And then I'm going to factor to solve this. But first, I have to get one side equal to 0. All right, to be continued. Your book assignment for tonight, I did promise I'd trim it down. I'm only taking off 4 problems. So that is right there. It's 3 to 21 by 3s instead of 3 to 33 by 3s. So the whole thing is going to be due Friday. Due Friday. All of this will be due Friday. All of it will be due Friday. I didn't finish the lesson. I can't make you